I'm Nate Beatty. I'm the co-founder and CTO of IrisVR. We're a New York-based software company. Thank you. A New York-based software company that's building tools to help 3D design professionals quickly and easily collaborate on design ideas and see them in virtual reality. So in practice, it works. Great. This means that we can get, we load 3D CAD models, or we provide software for designers to load 3D CAD models and view them quickly and easily using the Oculus Rift or HTC Vive. So you can do it with just one click in just a matter of a couple of seconds. So to start this talk off, I wanted to show a screen capture of a YouTube video of another talk on this stage. There's been a lot going on in virtual reality and augmented reality, and as Sofia Dominguez pointed out fairly recently here, there are a lot of terms that are thrown around. These are ubiquitous in the industry, but there's a plethora of terms, and this vernacular is getting pretty confusing. We have virtual reality and mixed reality and all of these different things. And I want to sort of lay the groundwork here at the beginning of my talk. These are all sort of one thing, as Sophia suggested. The digital and physical worlds are blurring, the lines are blurring, and we're on the cusp of this 3D revolution where we're going to be able to capture 3D space really easily. We're going to be able to view 3D space, digital 3D space really easily using things like the HoloLens, using things like the next generation of Oculus Rift and HTC Vive. So wanted to call attention to the fact that we need to focus on advancing all of the realities because all of these realities really are the future. Like I said, we're blurring the lines constantly between the digital and physical worlds, and this is something that I've learned, and my understanding of what virtual reality and what augmented reality, what immersive computing really can do has changed since I started Iris with my co-founder Shane about 3.5 years ago now. So I want to talk you through what I've learned and tell you a story, sort of a journey about virtual reality, my understanding of it, how it's evolved over the years, sort of in the context of building enterprise software. And the goal of this is to help you guys understand and to really build our collective understanding of what it means to build not just a demo in virtual reality that doesn't have a whole lot of replayability or meaningful impact in the long term, but to build something that can really be used, build meaningful tools that we can use on a day-to-day basis, and that really make this technology sticky. By the way, that was a picture that we took right when we started Iris about the immersiveness of virtual reality, and we climbed up to the top of the Flatirons to take that picture. Kind of a long story, but it was pretty immersive. Understanding space. So this is what we do. When we started Iris, we set out to load 3D models into virtual reality quickly and easily. So if you have a 3D CAD model, let's say a SketchUp file, a Revit file, these things are ubiquitous for people that are designing space or iterating on design ideas, people that are trying to communicate construction documents to the people that are actually going to build the buildings or build whatever environment you're trying to get built. We wanted to be able to load 3D models into VR, and that's important for a couple of reasons, right? You want to be able to see a model and experience it true to scale. And that was sort of our mantra, right, when we first started Iris. True to scale. We wanted everything to be true to scale. And you wanted to be able to walk into a building and see, hey, these ceilings are however high they are, 14 feet, right? And how does that compare to a 16-foot ceiling? Have a really visceral, innate understanding of what that means. We realized that the world was going 3D, so a tool that allowed us to just experience space in the way that it was meant to be experienced before it was built would be useful in the future. And we talked about this, understanding space, but understanding space and looking at a space, you're not doing a whole lot, right? You're just standing there looking around, and that's great for an understanding of space, inhabiting your designs. If you have a design and you want to inhabit it, you can observe it, right? We're talking about observation. That has a lot of meaning, a lot of power. Walk into a building and evaluate a design decision, that's important, and it was a great first step. And this is a demonstration here. This is actually a GIF of our current product where somebody's putting on the goggles and standing in their building and experiencing it for the first time. But beyond observation, what can you do with a 3D tool? What can you do with AR, and what can you do with virtual reality? And that's what I want to talk about right now. So we'll dive into part 2 of my talk, how humans communicate, right? How do we communicate? We communicate with words and text and all these different tools, but it's really been an evolution, and technologies have empowered us to communicate more efficiently in more practical ways, right, over the course of history. So we communicate in a couple of different ways, and there's a couple of different modes of communications that we practice. One of them is interpretive. Any good technology has to support these different modes of communication. So interpretive is like reading, right? Text, it's abstract. Somebody's going to write something down and then present it to another person, or not present it to another person, but hand this text to another person. They're going to read it and then have to convert that abstraction into something that they can picture in their mind's eye. Other mode of communication is interpersonal communication. This is my favorite form of interpersonal communication because there are no other people around. But this is, you know, if you're going to have a conversation, you have a dialogue, you have an ongoing dialogue with somebody else, then you can iterate on ideas more quickly, right? Any good technology for communication needs to support this mode. Same thing with presentational. Giving a presentation here, but when I'm giving a presentation, I need to consider my audience, right? I need to carefully craft what I'm going to pitch or say on stage in a way that I think the audience can digest. So a good communication technology should support the ability for somebody to give a presentation, give an effective presentation, and craft an experience and tell a story the way they really need to tell that story. So again, an ideal form of communication supported, you know, a communication technology should support all 3 modes of these communication that I just outlined above. It should also be able to, there should be like a big data pipeline, right? If I have written words, I can only communicate so much information. We need to communicate a lot of information as quickly as possible, and for technology to be able to make a meaningful impact on efficiency. Sort of in that same vein, it should be instantaneous, and there should be zero abstraction, right? So what you see is what you get is like an important aspect of a lot of the new efficient design softwares that we see with InDesign, right, early on, and now we use Sketch a lot because you can just drag things around the screen, and what you see is what you get. It's really an important evolution. So I have this graphic on a t-shirt from Microsoft Build where the last person is in virtual reality. I thought it was appropriate for this presentation because we talk about how, well, I'd like to talk about, and I'm talking about, how virtual reality has evolved, but I want to kind of stand this on its head a little bit and modify the chart. So we talk about the evolution of technology in terms of data throughput and abstraction, right? So an ideal that I described before is sort of down there on the lower right-hand side, where you're experiencing something, you experience a lot of information all at once. You can understand and comprehend it really easily because it's not abstract, right? So let's work our way through this chart. The written word, it's abstract. You read something on a page, there's symbolic words and gestures and text, right? You have to interpret that and paint a mental image. Audio and voice, I can convey more information with intonation, right? You get more understanding than just words on a page. So it's certainly a little bit less abstract, and I can convey more information in the same amount of time. Video, similarly, I can convey emotion, I can convey, you know, a sense, I can appeal to your visual sense, right, and convey information that way. But with AR, VR, MR, and reality, right, we can have a shared experience, and there's nothing more powerful than shared experience, right? So I can convey an infinite amount of information. I can convey instant understanding with immersive computing in 0 time. So that's high data throughput, and it's not abstract. You don't have to paint a mental image of where you're standing if you can see it. So to that end, I just want to talk a little bit about the kinds of data that we can convey and how we understand space in virtual reality and augmented reality. You can convey stereo depth, just to give you a sense of how rich this data format really is. You can convey stereo depth, right? So you can get a real understanding of like what distances objects are at in a 3D space. Audio cues. Audio cues are actually really important for our understanding of space. If everybody's really quiet, you can hear the room noise. Just the fact that the HVAC system is going in the background It kind of echoes throughout this space. You can close your eyes and get a sense of the fact that you're actually in a pretty big space. And that goes for small spaces. That goes out for outside, too. If you stand on the street, you hear the subway noise, or the taxi noise, as the case may be. It's very loud. You really, that contributes really meaningfully and more than you'd expect to your understanding of the space and understanding of your environment. The thing that a lot of people miss when they talk about 3D and why light field technology is important and exciting to me, it's a subject for a later talk, but focal depth is also important to your understanding of space. So we understand how far away something is, not just by our stereo depth, but if you focus on something close and something far away, your brain interprets that, and that contributes to your perception of the space as well, your perception of distance. And then relative position and motion. You know intrinsically, your subconscious knows intrinsically how far away your hand is and kind of how long your arm is, relative position of your body in space. And when you take a step through a space, then you really understand how big that space is because it's relative to you. So virtual reality, augmented reality, immersive computing in general is headed in this direction where we're positionally tracked, where the devices understand where we are in space, and they can create these experiences that make it feel like we're standing in space. And if they can make it feel like we're standing in space and moving through space, then that's another added dimension of information that we can get from one person's brain into another person's brain. They build a virtual reality experience to be shared. So in practice, how do we use this information in sort of this, I would say it's not obvious, but just sort of like the next step, right, in the progression of this technology, in communication technology, to actually make an impact in the enterprise? How do we stop thinking about immersive computing as a cool tech demo and a tool that can be used and add value on a job site or in a boardroom? At Iris, we think that means having effective meetings. We want everyone to have an excellent meeting, whether they're rolling out 2D floor plans or even better in virtual reality. Scope is one of our mobile products, and this is take-home VR. So this is interpretive communication, right? You can create an experience, you can create a stereo panoramic image, an experience that somebody can take home and look at. And that's sort of my corollary to that kind of anytime, anywhere, like a book, but it's instant understanding anywhere through the power of virtual reality. We also have the supported form of interpersonal communication, Multiplier. This is really important because people can actually share experiences in real time. They can have conversations about a space at the same time and evaluate design ideas in virtual reality. And that's a really powerful concept. If you have a shared experience, not only does it provide value while you're in the experience, you can say, yeah, these lights are not spaced adequately, or maybe we need one more over there in the corner. You can also, because you've had that shared experience together, reference it later on. You can have a conversation about the conversation that you had in virtual reality. So it has ongoing value and can be hugely impactful when you're making design decisions whether you're early in the design process or trying to communicate design ideas. In the case of Iris, on a project. Get my GIFs running. All right, viewpoints. This is perhaps the hardest interface challenge that we've had to overcome at Iris. That's presentation mode, right? What does it mean for somebody to give a presentation, the third supported mode of communication in virtual reality? And we started with viewpoints, right? So in your 3D model, in native 3D CAD, you have this concept of locations in space with states of an experience, right? So like with what lights are turned on and kind of where you're looking and maybe the time of day and some different things, right? But they're basically like waypoints. You can think of them as like waypoints. So we see designers and architects use these viewpoints, waypoints, to tell a story, and they can set up a certain sequence of waypoints for a customer or a client or a collaborator or colleague to step through in sequence, and it helps the architect or the construction project manager or the 3D designer tell this story of this space. But this is our first step towards viewpoints, and we're working on some ideas now having to do with how you actually give an effective presentation, and how you tell an effective and compelling story in virtual reality. So with that, we can talk a lot about the contexts in which Iris is used, and all of these involve communication, right? You can talk about interpretive communication and presentational mode and all these different things in all of these different contexts. And sort of in a business pitch, I can talk about how with better communication you can win projects, you can catch errors, you can justify design elements and reduce travel time because you can meet in a location, the location is a virtual model, from 2 remote locations, right? And those are all interesting and important, and they're important in the context of what we do at IrisVR. But what I want you to take away from this talk is that immersive computing should bring us all closer together through better, more efficient communication. It can really be used as a tool, and it should empower us to collaborate more efficiently on increasingly complex projects that were once impossible. So if we can communicate more effectively, if more of us can work seamlessly on these massive projects like we see all over the place here in New York, and that's a nice skyline from National Geographic. I think I pulled that image from of what's going up in the next 5 to 6 years, which is kind of scary. But then as a result, we can build all of these amazing things, and we've had Iris, our software, used as a tool on all kinds of different projects, from skyscrapers to rocket ships. And I hope that virtual reality will be used as an effective tool going forward. So with that, we'll open it up for questions, either about Iris or anything I've mentioned up here. Thank you.
Thank you very much. So from your perspective in the trenches of building a VR product and selling a VR product, where are we in the cycle, right? It seems that we're going up and down the hype cycle of VR.
Sure.
Where are we?
I think we've reached peak hype cycle in VR. I think it's probably sort of on a downtrend right now. And I think that can be said about the consumer market, though, right? And I don't think that necessarily applies to the enterprise, because I don't think we've seen yet VR used as an effective tool in as many applications as it could be. There can be a lot more done, right? I'm seeing a lot more people like finally grasp and understand what it means for virtual reality to be effective in the enterprise. We're seeing AR take off right now. So if we want to break down the terms and separate it out from immersive, separate AR and VR out from immersive computing, AR, I think because if we can see something in a space, you and me together, and just like look at it, but we can also see each other, not just representations of each other, but actually stand next to each other, then we can have that same kind of, we can experience something together, a virtual thing together, a digital thing together, without having to construct that experience artificially. So you get that out of the box with AR, and that's, in my opinion, why AR is sort of on the upswing in the hype cycle. Yeah.
Great. Questions? So you guys do AR as well? Is that essentially the same technology challenge, or not yet? Or?
In fact, we do. I just got a text message from a couple of the engineers back in the office who have a great version of Prospect, which is the name of our software, running on the HoloLens. So we're working on AR. It's another interface challenge, but it's very exciting to start having real prototypes of that coming out of Iris.
Your customers are developers, or the people who sell, the people who build, the people who design buildings?
Sure. Our customers are part of every part of the pipeline, right, of getting a building constructed. So I talk a lot about architecture and architectural design. And Shane, actually, my co-founder, gave a talk where he walked through sort of our customer breakdown. But architecture is that he comes from an architectural background, and we have some architects in-house at Iris, and we focus on that use case, which is why I say architects a lot. But architects are the first part of the process of getting a building built, right? And all the way throughout the rest of the pipeline, when you talk about design iteration and the people that actually commission the project and present the initial RFP, and the people that actually have to put up the sheetrock, and all the construction contractors and subcontractors and all the people that install the MEP systems. There's thousands and thousands of people, depending on the project that you're talking about, that may collaborate on getting a building built and that are constantly reading two-dimensional plans. So Iris is used, you can think of it as immersive design review, right? So anytime you're rolling out 2D plans, anytime you have to look at a design and figure out how that piece is going to fit into that other piece, or if you can fit your drill behind the radiator that you just installed, installed the mullions in the windows. Anytime you're having those kinds of conversations, you can use Iris, and that's where it's used.
Great. One question over there.
For the 360 panorama device that you have,
sure.
Can you talk a little bit about the decision to make that like a hardware-based proprietary system versus using mobile phones or something that you could just connect?
It's actually, it is mobile phone based, and it's the goggles that you saw in that picture. Let's see if I can, well, it's a lot of slides back, but I'll post my slideshow, you can see the picture. But it's, that's a Gear VR. So that's a Samsung phone snapped into a plastic housing that is, it's available. You can go, grab a Samsung phone and a Gear VR. I think they're $50 now or so. Sure.
Can you talk about a bit of that balance between trying to be more and more photorealistic with higher data rates versus trying to go mobile? Where do you kind of feel that balance is at right now, and what are you guys aiming for?
Yeah, that is the question. That is the question that we struggle with a lot at Iris, because that is a careful balance right now, because there are performance constraints and requirements. We made the decision early on to make sure that we were focused on user comfort and performance at the cost of all else, right? Always. And I think that's important, because if you're trying to present your design ideas or you're trying to have a meaningful conversation, you don't want to get sick. So that's something that we have to consider when we're designing things in any sort of immersive computing environment. And as a result, we can load really large files and hit high frame rates, whatever device you want to run on. Right now, we're thinking a lot about that balance between photorealism. I think there's a minimum bar that you have to hit when it comes to photorealism, or just, an approximation of photorealism so that things look nice, right? Once you've hit that bar, I really think the most important thing is providing the array of tools that allow people to communicate most effectively. So if we can have a multiplayer conversation, a conversation, just period, where we're both standing looking at the same thing, and that thing is digital, it hasn't been built yet, we can talk about that, and that it's valuable, that's a valuable, meaningful conversation. That is way more effective and way more important than it looking nice when we're trying to actually get something built. Yeah.
All right, one last one, quick one.
Good toss.
Just real quick on the decision to be a hardware and a software-based company, and the pros and cons that you weighed off, and how it was like working with the different partners like Oculus and like Vive, and just kind of what that process was in making the determination to provide both.
Sure. So let's see, we're purely a software company, but we have a lot of integration with these hardware partners. So we don't manufacture any of the hardware, but actually like getting distribution of the hardware into architecture firms or construction firms. We might go down that road at some point. At this point, though, we're purely software. But it is working with all of this hardware and having it. I mean, it is sort of a fundamental part of our offering, right? Because firms don't have this yet. It's not like a cell phone that we all have in our pockets. We can all download an enterprise app and just run it. So we do a lot of educating about this early hardware, and as the hardware iterates faster and faster, we do more and more educating, right? Just what is the difference between all these different things, and AR and VR and MR and XR that come out. So that's been a major challenge for us. We decided to build on top of a game engine. The actual in VR part, we have a lot of other components to do pre-processing and get model data into VR, right? But the in VR part is built on top of Unity, and we like the game engine for the reason that it's interoperable between a lot of different, hardware sets. So they take care of integrations for us to a certain extent.
All right. Thank you so much. I appreciate it.
Thank you.